Many thanks to PCBWay for sponsoring this video. Good day everyone and welcome back to the X-Explorer for another video. I'm Yankee Oscar 6 Delta X-Ray Echo, and from the title you can tell that today we're going to return to an older project, the mini-whip antenna. Not because I'm trying to repeat myself, but I'm trying to make some sort of step-by-step instructional video on how I'm building this one, just for the people that would like to order the PCB boards. And this way you get to see the way I thought about installing this antenna in the PVC pipe enclosure. So I hope it's going to help. Now the thing is that I built the first version, the prototype, in earlier videos, and I was really impressed about the performance, especially because of the fact that I did not install the antenna the proper way, with all the tips and tricks and recommendations from the original article to get the best performance out of it. And still I managed to have some decent performance out of that antenna on top of the mountains. I was really happy. So because I'm trying to slowly start preparing my camper to start moving around, I thought it's about time to make an antenna that is easy to deploy, and it's going to be available like a multi-band antenna to allow me to at least receive, just because I know that I might not always be able to install antennas that will allow me to also transmit, not just receiving. And since it's a multi-band antenna, I think it's a great way to start with something. Now today I'm just going to cover the mini-whip itself. We're going to talk about the bias T, and we're going to test the antenna in a future video, part 2 probably, because I'm still waiting for some coaxial cable and some connectors that I ordered, and I'm not sure when they're going to arrive. So depending on how fast the order comes, that's when you're going to see the video. They might not be in order. I might post other videos in between, but you'll find it anyway, because if you subscribe to the channel, you always get notifications, I believe. So anyway, we're going to take care of this one really quick, finish it. I'm not going to respect the instructions that are given into the older video when I was trying to make that antenna to also perform better on the VLF, just because I have other plans for VLF. Probably I'm going to end up building some different sort of antennas. Today I'm concentrating to get a good performance on the HF bands, so basically somewhere from 1 megahertz up to 30 megahertz, and if it performs well in these frequencies, I'm happy enough. So anyway, I'm not going to continue without saying thank you to my friends at PCBWay for always supporting the X-Explorer channel. Remember, they have great PCB prototyping services, PCB assembly, SMD stencils, CNC 3D printing, and a lot more services available for you. Don't forget about the module store, where you can find interesting things that might be useful for your project. And remember, I always like ordering both from the module store and also PCB boards, so they can all arrive in one package, just to keep the expenses low when it comes to postal services. If you don't have an account for PCBWay, have a look down in the video description. You'll have a link that you can use, and you'll get a discount on your first order. Remember, as I'm always saying, PCBWay is the way. Well, here we are. We're going to start putting this antenna together. I had to stop filming yesterday, so good morning. It's the next morning right now. The wind was too crazy, the rain was blowing like crazy, and my my camper was shaking. Just like weekend days in South Beach, Miami, aboard my sailboat, when the people with jet skis used to come around, and my boat was going crazy because of the waves. So I used to take my bicycle and just go for a bicycle ride on the beach to get away from that. So anyway, I'm not going to make you watch me soldering components on the board, and I'm talking to the people that are beginners in building circuits. The only thing that is important for you to know is just to make sure that you're measuring the components every time you put it on the board, to make sure that you have the right value in the right place. And you can use anything like a tester, or maybe like a multimeter, anything to make sure that you install it the right way, and there's no way you can make mistakes for the antenna not to work. Now, I had an issue in the past with, I think, with some transmitters that I designed. where the footprint of the transistor was wrong. Basically all I did was to use the footprint that I found in the library online, but apparently the one who designed it designed it the wrong way, because the pins were not properly aligned the way they're supposed to be. So it turned out that I had to double check, modify the footprint, and then redesign the entire PCB board to fit the new footprint the correct way, basically. So I went through all the designs so far and I modified everything. This mini-whip antenna is the last one that I didn't check, but I hope it works, because so far nobody complained, so it should be alright. Anyway, what I wanted to talk about is that yesterday I said that I'm going to build the antenna using the most common way found online, basically using 100 nanofarad capacitors, because I'm interested mostly in the HF band. But I changed my mind, because I thought, like, okay, maybe I will be interested in a VLF using this antenna. And because I don't have 560 nanofarads capacitors that are required in the original schematic, I decided to use 1 microfarad capacitors. And if you watch the older videos, you already know that increasing the value to 1 microfarad, it will also improve the performance on VLF. Unfortunately, I don't have non-polarized capacitors, so I'm going to use this 1 microfarad tantal capacitors. I think these are they work up to 35 volts. But remember, they are polarized if you use these ones. Make sure you install them the proper way. Basically, the minus will go to ground, and you know, that sort of thing. Just because I learned this the hard way. I didn't even know these tiny capacitors are polarized in the past, and I blown a couple of them, and I was wondering what's going on and why they keep blowing up. Well, now I know. But I'm going to use this instead, just to make sure that the antenna will perform well on VLF as well. So anyway, I'm wasting time here. The video is getting long. Let's make it short. I'll be right back as soon as I put all the components on the PCB board. And yeah, we can talk a little bit more after that. Well, I stopped a little bit. I soldered pretty much all the components except the capacitors and the LED, and of course the connector. I'm not going to solder the connector and the LED. We'll see later on why, because first I have to figure out the enclosure and how everything will fit in the PVC pipe. But I wanted to talk really quick about the capacitors. Basically, I realized that in order to have a good performance on VLF, I don't have to replace all the capacitors with 1 microfarad. So basically, I'm just going to replace C3 and C4 over here. These two will be 1 microfarad. You have to be careful with the polarization of the capacitor, and I'll show you in the schematic how we'll do that. And we're going to double check on the PCB board as well. And these two, I can't see, C5 and C2, these two will be 100 nanofarads capacitors, because I'm trying to save this just so I can also finish building the bias T, which we're going to talk about in the next video when we're going to do the antenna test. So okay, if you look in the schematic, the positive side of the capacitor, I'm going to show you both for C4 and C3, it's going to go in the side where the transistor is, and the negative side basically obviously will go in the opposite side. So now going back on the PCB board design, if we look over here, we have to check on the bottom to see which one comes from the transistor. So it's this one over here. This will be the positive and this will be the negative, and as we turn it around, this will be the positive, this will be the negative. This one goes to a resistor. Okay, and on this capacitor over here, the one coming from the transistor. So basically this one over here will be the positive, and here in this side we'll have the negative of the tantal capacitors. So that's the way I'm going to solder them. Alright, we're done. That's it. There's really nothing much to do. It takes about 10 minutes to solder all the components on the board. Again, I didn't solder the LED and the connector. All I have to do is just to clean it up on the back a little bit to get rid of the excess stuff and clean it up with a brush just to look nice. And we're going to start working on the enclosure, on the PVC pipe enclosure, trying to fit it properly inside with the connector. And the last, we're going to solder the LED depending on the position of the antenna on the cap of the PVC pipe. Alright, looks great, I like it, and hopefully it will work. Alright, let's start talking about the enclosure really quick. So I have the finished board over here. I have a piece of PVC pipe with two end caps like this. They will go inside. Because I don't have so much stress, it's not a water pipe, I'm going to cut them in half so it'll be easier for me to place them. Both of them, one in one end, one in the other one. The one that it goes on top, it will be fixed with super glue, just to make sure that I don't have any water coming in. So I'm going to pretty much make it watertight. And then the one on the bottom, I'll have to make sure that I cut enough that it will allow me to solder the connector once it will be placed inside over here right in the center. It will allow me to have enough space to solder that connector to the board. And also I'll have to make enough space that I will also place an LED right next to the board and next to the connector on the end cap, just so I have an indicator when my antenna is on, and to make sure that I have power going into the antenna. Anyway, I drilled the hole. It's not really dead in the center, but it's good enough, I guess. I can still fit this properly over here, as you can tell. I cut this one, as I was saying. I'm not sure how much I have here, maybe 1.5 centimeters, 2 centimeters, something like that. It goes inside just enough to pass the rubber inside. This will be the bottom basically, so I can always open it. Now on top I remove the rubber from the tube, and this cover over here, this one will be glued permanently with some super glue and insulated very well. And that's because at the end, once I finish everything, I'm going to also spray it with some UV protected varnish from a spray. So all I have to do now is to figure out the position of the LED, and also to cut a little piece of copper sheet to create the ground connection for the antenna. So basically the entire antenna will hold and stay into that one pin from the connector. Now of course, if you want, you can place some sort of like a little cross over here from PVC pipe if you want, on top of the antenna, just so it will fix it and it will not move around. Sorry, I was doing that off camera. Once you place it inside, basically it will fix it inside the PVC pipe and will not move around, so you don't put too much stress on the connector pin itself. But yeah, I believe this one should work. I'm not planning to remove it that often. Doesn't matter how much I move. Okay, I'm done. I'm ready to put it together. So I prepared the space where the LED will come. I fixed the connector to the PVC cap. I also placed some super glue underneath just to make sure that it will be insulated and there's no humidity coming in. And over here, just as I said, I fixed the end cap with super glue over here, and before placing the final piece to the PVC pipe, I'm going to go outside and spray this one with some clear varnish, UV resistant. And yeah, this is done. All I have to do now is to fix the PCB board to the connector itself, and I just figured that the easiest way it's actually to solder it this way on the back. So I will solder it like this, and after that I will make sure that I'm also doing the connection between the ground of the PCB board to the copper washer that I created. I made that washer from copper just because I didn't have the original washer that comes with the connector that you can usually use basically. So I'll just put a short piece of copper wire, silver plated copper wire that goes from the ground of the PCB to the copper washer. So again, the center pin of the connector, it's soldered to the center pin over here. Then this one on the side, it's basically soldered to the washer that I just made from copper sheet. That's the ground. And over here we have the LED connection made on the back of the PCB board, not in the front, just because this was the best position for me. So first I inserted the LED, I glued it with a little bit of super glue just to have it fixed over there, and then with some pliers I introduced the terminals into the little holes, and I soldered everything back in place, and that's it. Now I've been testing it, it fits perfectly into the PVC enclosure, it all goes well. Okay, final test. I turned on my power supply. I have two connections over here, and I'm going to power the antenna really quick. Alright, there's power on. Let's see. I'm going to keep it powered on for a little bit. I don't see any smoke coming out, so I guess at this time everything works fine. Let's see, there's no transistor heating up. Okay, well, the only thing that I'm worried about is just that about the problem that I was talking about at the beginning of the video, when it comes to the pinout of the transistor and the footprint that I downloaded from the online library when I designed the circuit. So it seems to be fine. Alright, the antenna is ready, all set, it works, there's no smoke coming out, I'm happy. The only issue that I have is that you know, the connector is just a little bit higher, and it will not fit perfectly in this PVC pipe, but it is what it is. This is the only standard dimensions that they have. They don't seem to have longer ones, so I'll leave it as it is. I sprayed 2 layers of varnish on top. I will have to spray a couple of more just to make sure there's no moisture going in. This one is still very secure because it stays in the rubber that is inside the PVC pipe. There will be no moisture going in, and the wind will not be able to take it out and remove it anyway. So yeah, I'll see you in part 2 of the video, depending on how quick my connectors will arrive, but that's when we're going to finish building the bias T. We're going to install the antenna outside the proper way, just as it is recommended in the original article, and after that we'll do a quick test, and that's it. I have a nice receiving antenna that I can use very easy and deploy the same way. So I'll see you soon. Thanks so much for watching. I apologize if I talk too much. I'm trying to give as many details as possible for those people that are not very much DIY inclined. and that's the reason some of the videos might turn out to be very long. It's a lot of talking, but it helps a lot of other people that might not be so much into this DIY thing as many of us are. So thanks again. 73 from Yankee Oscar 6 Delta X-Ray Echo, and I'll see you very soon with another video.